problem. Today we're talking about density, and we see that density is equal to rho. That's the Greek symbol there, rho, and it's mass over volume, or mass per unit volume, basically saying how much stuff something has per the volume. So we're going to have units, mass is kilograms and volume is meters cubed, so we'll have kilograms per meters cubed for our answer. We can also see that we can rearrange this equation where mass is going to be density times volume, which will become very important when we get to buoyancy in the next couple videos. So let's just do a quick example. Let's say we have a wrecking ball and it's going to be swinging there, and obviously it has a mass, and we want this to have a lot of mass. And because when something has a lot of mass, it is not only massive, but it has a lot of inertia. And if a lot of inertia means once something gets going, it wants to keep going, and it usually goes through things. So we're going to make this out of, I don't know what we're going to make it out of. Let's make it out of gold. Why not? Density of gold is 19,300 kilograms per meter cubed. If I remember that number off the top of my head. And what we want to find out here in this problem is, let's find the weight of wrecking ball with a radius of 1 meter. So that's a pretty big wrecking ball, and made it out of gold would be even more worthwhile, but let's just for silliness, we won't worry about it that it's made out of gold. We're just trying to use some different numbers here. So there we go. How do we find out the weight? Well, we know from earlier that weight is the force of gravity on something, and the force of gravity on something is mass times gravity. Since we've already rearranged this idea of density with the mass, we can change that to density volume times gravity. So we're going to put 19,300 in there for the density. What do we put in the volume? Well, if we're saying this is a radius of 1 meter, volume of a sphere, assuming it's a big round globe, is 4/3 pi r cubed. And as I've told my students, whenever you see pi in something, chances are they're talking about something circular or round. That's, you know, the pi r squared, 2 pi r, pi over 2, 3 pi over 2, all that kind of stuff from trig. So 4/3 pi r cubed, what does that come out to be? 4/3 times pi times radius of cubed of 1. That's why I picked the radius of 1. That's going to be 4 times 4/3 divided by 3. Looks like it gives us about 4.19 meters cubed, and that's going to go up into there, 4.19, and gravity is 9.8. If we go through all that mess, times 19,300, pretty heavy. Let's see, 792,267 and change newtons, 792,267 newtons. Pretty heavy wrecking ball, but obviously made out of something very dense, which is why they look for gold very low in the ground, because the denser things sort of work their ways down there. And a radius of 1 meter means it's sort of twice as wide as a refrigerator box, a little more than that, to give you a ballpark. It's a nice big wrecking ball, so very heavy. We divided that by 4.5. It gives you a ballpark about 176 and change pounds. If we converted that to pounds, which is dividing that by about 4.5. Nothing you really need to know, just sort of putting it in an idea of pounds instead of newtons. So real quick problem there, kind of silly using gold, but just using a density problem. Alright, see you on the next video.